All right, students, it's time to talk about Newton's third law. Now, this law is the most messed up of the laws, not because it itself is messed up, but because people tend to use it wrong. Newton's third law is an explanation of the behavior of matter that says for every force, there's an equal and opposite force. Now, this is really different from cause and effect. Cause and effect is an action and a consequence. If I punch my brother, he's going to turn around and punch me back. That's not an equal and opposite force, that's just family. For every force, there is an equal and opposite force. What this means is that if I push on the wall is also pushing on me. When I'm pushing down on the ground is also pushing back up on me. The only difference between the two forces is the direction. Now, the two objects may accelerate differently as a result of the forces, but it's one push viewed from opposite directions. Let me show you an example. Early on, there were a lot of skeptics who didn't believe that rockets would work in space. They didn't think that rockets would work in space because they thought that if there was nothing to push off of behind the rocket, that the rocket wouldn't be able to fly forward. A lot like when you're underwater in the pool, you can push off the wall and jet forward, but if there's no wall, you can't push off it. But that's not how rockets work at all. Rockets work by throwing hot gas out the back, and the very act of throwing the gas out the back pushes the rocket forward. When it pushes the gas backwards, that hot, high-energy gas, it gets pushed forward. If you apply a force to an object, that object applies a force with the same magnitude, but in the opposite direction, right back at you. Let's take a look at that rocket example. This is an X-Wing from the Star Wars series. This X-Wing is capable of throwing hot gas out the back of the rockets. That hot burning gas pushes that way. And when that happens, when those gases get pushed backwards, at the same moment, the rocket gets pushed forward. The amount of force is equal, but in opposite directions. There are a lot of different examples of this. One that comes to mind for me is when I was teaching my daughter how to ice skate. She'd crouch down on her ice skates, and I'd stand behind her, and I'd give her a push, and she'd go flying forward. At the same time, I'd end up moving backwards a small amount. I gave her a push. Now, she has a small mass, so she accelerated forward greatly. I have a large mass, so I only accelerated a little bit. The forces were equal. My push on her at the exact moment caused a push from her to me. The same force viewed in two directions. See if you can come up with an example on your own.